All right, today we are going to talk about section 6.2, talking about if a line is perpendicular to a plane. And the main theorem that we're talking about in this section is if a line is perpendicular to a plane, then it is perpendicular to every one of the lines passing through its foot. So in this case, if we have a line, first of all, we have this plane, and we'll call this plane M. And if we have a line, say AB, that is perpendicular to plane M, as the line goes through the plane, then it is also perpendicular to line AB. It's perpendicular to CB, it's perpendicular to DB, and it is perpendicular to EB. Because those are all lines passing through the foot, which is point B. So if we have this and we can visualize PF as a, so if we can envision PF as a vertical lying in the plane here, going through plane M, then we have lots of different angles that could be right angles. We could have angle PFA being a right angle. We could have angle PFB, angle PFC, and angle PFD, because those are all going through the foot at point F. So again, we need to visualize PF going straight through the plane of M. Go ahead and pause the video for a second here, looking at this problem, and see how many right angles you can find. After doing this, we can see that there are 12 right angles. Because it says that ABCD is a square, we have the 4 right angles down here. We also have that the diagonals are perpendicular, so we have the 4 right angles there. And then also, because PF is perpendicular to T, we have the 4 vertical right angles coming down with PFA, PFD, PFC, and PFB. So there are 12 right angles. In this one, this proof is very similar to a proof that you guys were doing yesterday, but we have one extra addition here because we have that it is perpendicular to the plane. So in this case, we start off with AD is perpendicular to plane M. And then we can say that AD is perpendicular to DB, and AD is perpendicular to DC. A reason? If a line is perpendicular to a plane, then it is perpendicular to every line passing through its foot. And yes, you do need to write down all of that. And then after that, we can say that we have right angles. I'll call them angles 1 and 2. And we have right angles because if perpendicular, then right. After we say angles are right angles, we can say that those angles are congruent to each other. And then after we say that they are congruent to each other, we could finish the proof with the given information of ABAC, and we have a reflexive step to finish proving that the triangles are congruent. So you can go ahead and finish that proof and with that for tomorrow. And that concludes section 6.2.